you can hear that on the other side, but the robot lady is talking to me that the broadcast is starting, and it's just so exciting to be here. Everybody, welcome and happy Tuesday, happy September. I'm not sure the last time that we've spoken, but cooler weather is around the corner, I promise, and all the pumpkin stuff is already starting to come out. So fall is on the way, and I'm just so happy that football is back as well. But today we have a fantastic training for you with Miss Heather Bjorn and Steve Tessier. Did I say that right? I know Steve's muted.
Tisher, close enough though.
Tessier. There we go. I messed it up. I'm hooked on phonics, so the IE always throws me off. But ladies and gentlemen, we are going to be going over the OBM, the bridge design, 3D modeling, and plans, and how to. I think you're going to do tips and tricks on how to QC a bridge. But no one signed on to listen to me blab on. So Miss Heather, I'm going to turn it right on over to you, and I'm going to be in the background in case you need me.
Sounds good. Thank you very much, Brian. Morning, everyone. Excuse me. So like Brian said, this is the 2025 FDOT District Update Training. This is for OpenBridge Modeler, FDOT Connect for OpenBridge Modeler, and we'll be going over some tips and tricks for model-centric plans. And before that, we'll be going over how to QC a bridge model. So we'll click through the agenda in just a moment. So introductions, myself and Steve will be giving the training today. For those of you that don't know, my name is Heather Bjorn. I have been with WSP for 10 years now. I'm a senior structural engineer, and I have been working with OBM since 2019. And I'll let Steve go ahead and introduce himself.
Thanks, Heather. Yep, like you said, my name is Steve Tisher with Atkins Realis, senior structural engineer over here as well. And I've been using OBM, I think, pretty much since the day it came out. I remember Sri, the product manager, came to our office when it was just coming out and trying to pitch it to us. And I can say it's come a long way since then. Been working with FDOT and the workspace for probably about the last 6 or 7 years, and looking forward to the training.
Cool, thank you. So the format of the training today is lecture with some live demonstrations mixed in. So it's not a like a hands-on training. So there's no like data set or anything that we sent out to you guys to like follow along on your screen. So it is going to be more lecture based. So just kind of like pay attention. And then we will be doing some live demos. So if you have a bridge model that you'd like to click around in and try to follow along with what we're doing, you're welcome to do that. We will be using the FDOT OBM training guide data set. So the bridge that you'll see on the screen is the same bridge that you end up with when you go through the FDOT OBM training. So if you have not gone through that training already, I would very much encourage you to. If you did it several years ago, we did go through and update the training to I'll say a more interesting bridge. So if you haven't done it in a while, it's worth another go through. And then we'll go through questions at the end of each topic. So I'll go through what those topics are in a moment. So here's the agenda, introductions and agenda. That's where we are right now. So topic 1 is how to review and QC a bridge model. So these are approximate timings. We'll see where we land, but that should take about a couple hours, maybe hour and 45, and then we'll take a break about midway through. And then topic 2 is where we'll go over model-centric plans, tips and tricks. And then at the end, we'll just have a few minutes for closing and any final questions. All right, so let's jump right into it. So how to review and QC a bridge model. So that has been one of the bigger challenges, I'll say, when we start moving toward model-centric design and model-centric plans. So when you first start, there's kind of a limited number of people who are I guess who have the capability to develop some of these bridge models, right? And if there's only a few people who can develop the bridge models, then who has the expertise to QC them? So when we do QC for calculations, right? Like if you're doing QC for a pier design, you have to know how to design that pier before you can QC it, right? It wouldn't make sense for you to check it otherwise. That's not necessarily the case for bridge models. We do use like a hybrid approach for how to QC these OBM models. So we do have documentation and PDFs that we print out that we can go through and yellow highlight. And we have on the left there the 3D bridge model QC checklist, and that is something that is currently under development right now. So we put it together, and I'll show you the draft version of it. And then eventually that will become an FDOT aid for people to download, follow along, and use it as their checklist as they're going through and QCing the bridge model. Everybody loves a checklist, right? I think so. When again, part of the challenge of doing model-centric design is knowing how to QC the model, and I think that that's where some people have been kind of struggling or lost to, what do I check? And that's why we've gone through and developed this checklist. So you do have to kind of have a hybrid approach when you're modeling, or sorry, when you're QCing bridge models. So you've got your documentation, and we'll go through what all makes up a QC set for an OBM model. And then in tandem with that, you have to jump into the model, right? So you don't, again, have to be able to create that model, but you do need to be able to like navigate around. So that is what we're going to be going over today. So on the left, again, is the first page of the 3D bridge QC checklist. And the items that are in your QC package will be a write-up of the model status. So just, discussing anything that's unique about the model, anything that people would have to know. And then you have the input echo report, the bearing report, horizontal and vertical geometry reports, super elevation report, if there is one, and then the model element breakdown workbook, which can be found in the CAD manual, and then this 3D bridge model QC checklist. So those are all the pieces that make up the OBM QC documentation. So these are the sections of the OBM QC checklist. So like I mentioned, this is a preview, right, of this document. It is not published or available yet, but it is in the works. But it goes through. There's a section on just general review of the model, just ticking the boxes, making sure everything's in that QC set. And then we go through and we talk about the input echo report, right? We have a line item for everything that should be in that input echo report, and then you go through, you check each of those items. While you're doing that, you go through and do the visual inspection of that those elements for the model. And then once you've taken a look at the input echo report and done that in tandem with the a visual inspection of the model, making sure everything looks good. Sometimes if the geometry is unique, you'll go through and you've got all the input right, but you still have to visually look at the element because there might be something that didn't come through as anticipated. So again, just a lot of checklist items for you to go through in the documentation, as well as the model, and you can set the status for all of those. So the next section is calculations and design, right? So obviously you need to make sure that the model is reflective of the actual structural calculations and the structural design that's been done for this bridge. And again, we have a checklist here, elevation verification. That's one of the more important elements. You want to make sure that all of the beam seat elevations are as expected, the cap edges for both the end bend and the pier caps, that the wing wall and cheek wall are modeled as anticipated, that the pile cutoff elevations match, and then once you have the geotech information, that the pile tip elevations match as well. And I won't go through all of this, but every element that you have a design for, you want to jump into the calculations, assuming that they're done, and then kind of compare the geometry and make sure that your model matches your design. On the right there, we have the SDG, SDM, standard plan, dimension agreement, right? So this can be done as a part of your, if you do a 2D layout, right? When whoever goes through and lays out the bridge initially, whether they jump right into to 3D or whether they start in 2D and move to 3D, at some point you have to do your checks to make sure that you are meeting all of the geometry requirements of the SDG, SDM standard plans. So that's not something that's unique to bridge modeling, obviously. We've gone through and listed the elements that make their way into the bridge model. But again, this is nothing new. Anytime you've designed a bridge, you need to make sure that you meet the approach side length, that the clearance between the beams at the piers, the clearance between the beams at the front face and back wall, minimum cap dimensions, that all of that is met. We just kind of put it in the checklist so that you can go through and confirm that the model meets all of those requirements. Again, as you would always do. After that, you want to make sure that you have concurrence with other disciplines, right? We want to make sure that the roadway alignment and profile. So in order to develop an OBM model, you have to have an alignment and a profile, which is generally provided by the roadway team. So you do want to make sure, right, if that roadway alignment or profile gets updated for whatever reason, that we're aware of that, and that the horizontal alignment and vertical profile that we're using matches the latest in the roadway plans. The other thing you want to make sure is that we do a visual check for concurrence with roadway models, right? We want to agree, or we want to make sure that the deck limits, the widths, the cross slope, the elevations at adjacent locations, that all matches. So you reference in the roadway model, onto your bridge model, and then you make sure that those jive, right? And then another important thing is utilities, right? If you've got the proposed and existing utilities, you want to make sure that there are no conflicts, or that if there are conflicts, there are plans for relocation. Always keep in mind the accuracy of the information that you're bringing in, right? If your utility line work or model is just using an assumed depth, and there's not actually VVHs to confirm that depth, then you take that with a grain of salt. So as with always with utilities, you could have a if you were doing clash detection, which is a tool that you can use within OBM to check hard clashes, so direct conflicts, or soft clashes, so within X feet. Just keep that in mind when you're doing checks with utilities, existing utilities, because there's a little bit of uncertainty with that. So you could go ahead and give that an envelope of tell me if I've got any conflicts within 3 feet or 5 feet of an existing utility, because depending on that level of confidence. All the other disciplines as well, right? Drainage, proposed and existing. Make sure that there's no conflicts with any of the footings or piles, and just double check any inlets or pipes, any other drainage features on the bridge. Same with lighting, as we would do in 2D, cross-reference the design files and make sure that any bridge-mounted light poles or fixtures are accounted for, and that there's no conflicts. You do want to go through and, one of the more powerful things that you can do in OBM, and we'll talk about that a little bit later, is clearance checks, right? So you've got your bridge modeled in 3D, so you can then use that model in tandem with either proposed, roadway corridor, or potentially an existing terrain file, and you could do your vertical clearances, and you can also do horizontal clearances. If you've got the the MSE walls modeled in there, you can go through and do all of that with the models. MOT and phasing, nothing specific to models there. Just make sure if the bridge is phased, that we know that it's phased. You don't necessarily need to model the phases separately unless it's a project specific requirement. So you could go ahead and just model that as built condition of the bridge. All right, so that went over the QC checklist. So I'll actually jump into the file itself real quick and we can just scroll through it, and then I'll jump back into the presentation and we'll move on to the OBM generated reports. So I'll just jump into here real quick. So this is the draft version of the OBM QC checklist, right? So this is where all the screenshots came from. Here are the items to include in your bridge 3D model QC package. And then each of these elements, again, checklist you go through, check whatever, and then you change the status to, got completed, no comments, turns green. If you've got completed, but there are some comments, it's this orangey color. So then you add in your comments here, and then the originator would have their response here, and then you could go through and close out your comment. And then we've got this kind of defer type comment, address in future submittal, and then we've got not checked if it's not something that was checked during that submittal, and then we've got not applicable. For instance, this is tub girder groups, right? If you don't have tub girders, then that's not applicable. Then again, this is all just basically what I said, screenshots of, or I put screenshots of in the model. So there's a spot down here for additional comments. If you have any comments that are outside of the kind of the general categories that we have, that those would belong down here. We also have the start of a 3D bridge best practices guide. Those are just some items that are not, necessarily things that are official, but they're things that we, recommend as good practice. And then there's also a BIM review log, which is in the FDM as a requirement, and then the post QC change log. Those are two kind of future items that we'll be working on. So that's the QC checklist. So now I'll go through and talk about documentation to review. So these are other elements that are listed in the OBM QC checklist, right? To make sure that they're within the QC set, the PDF that's printed out as documentation for QC. So on the left, you'll see the civil geometry, right? So that's our horizontal alignment review report and our vertical alignment review report. So something to keep in mind with these reports is that you you control the precision and the units in OBM. So you can see when I printed this, the units were, master sub and then decimal here. So could go through and change that in the design file and or in the file, and that'll control how these are displayed. So what I'll generally do, right, sometimes these alignments are very long. So I'll go through and put a box around, where the bridge is on that horizontal alignment, as well as on the vertical profile. So you just, find the stations of the bridge and put the box around it to let the QCer know, like, hey, you don't have to necessarily worry about all of this other, hundreds and hundreds of feet potentially of roadway alignment. We are really focusing in on where the bridge is. So that is just a recommendation for when we print out these reports. And again, you can compare this with the latest roadway geometry and confirm that the alignments that are printed out, or the alignment that is printed out, is the alignment that is being used for the bridge, right? So each bridge model in OBM has an active alignment, and you just want to make sure that the one that is documented and the one that is intended to be for the bridge is in fact the one that is set as active. And I'll go through after this section, and I'll jump into OBM and we'll generate some of these reports live. So we'll talk through that in a little bit. So that's on the left, the civil geometry reports. On the right, we have the OBM input report. So the OBM input report is or can be a very long document. right? So this one, you probably can't see, the text is probably too small, but is 39 pages. And this is, I believe, for a 2-span bridge. So this is basically everything that you put into OBM to generate this model, then gets echoed back to you, tables and tables. So this is really good documentation to go through and use as you're checking, right? So you go through and it's got, for example, these support lines. So we've got our, begin approach slab, where the approach slab transitions, front face and back wall. So we've got the station and then the skew of all of those. The length is the length of the support line itself, so that's not necessarily super meaningful, but again, you have the station and the skew of each of those lines. So you can go through and use this as your, everybody likes highlighting something when they're QCing. So you can go through and use this, highlight it, say, yes, I checked this station makes sense. It's as intended for the, begin end approach slab, begin end bridge, stuff like that. It does go through in detail things like variable constraints, right? So if I have a bridge deck and it had the template had a set width, it also, if you go through and use variable constraints to vary the width of that bridge, it will in here detail whether these variables are active or not active, and what that transition is. So if you use a super elevation model and you use that to control the super elevation transition on a bridge model, that information will then get conveyed into this variable constraints. So this is where you would see basically the super elevation transition information come through for the bridge model. So you could check that against, again, the super elevation design. And that would be the same if you did this manually as well, if you did any manual variable constraints. So again, this is just kind of 2 examples. We'll scroll through the OBM input report for the training guide model, but a lot of good and helpful information that basically documents everything that was put into the OBM model. So on the left here, we have the deck elevation report. So the deck elevation report, as you can probably imagine, can be used to help generate or QC finished grade elevations. So there are settings that you can go through and use and set for this deck elevation report to exactly mimic what is required in the STG for finished grade elevations. So this is very, very powerful. You can, again, depending on your level of confidence with it, maybe the first couple times you use it to QC the finished grade elevations and to develop that confidence in the model, generating what you'd like. And then after that, maybe you use it to generate your finished grade elevations, and that's a great time saver there. And we've used it for many years. It's very accurate, and at this point we're very comfortable with using it. So again, there is some setup required in the settings to make sure that you get the T-lines oriented properly, and yeah, just there's different formatting settings for that. We'll look at some of those settings in a little bit, but that is again, you can go through and within the report itself, you can adjust the precision to give us those 3 decimal places that we use for bridge elevations or for bridge deck elevations. So that's a great one. Probably I guess the best time saver, I would say, in terms of the OBM generated reports. So after that, we have some other reports, right? These are the beam reports. So it goes through and gives you all the information that you would want to know about beams here. So it gives you elevations at 10th points along the beams, and it also gives you haunch thicknesses along the beam as well at the left beam center line and right. So you can go through and compare those with design. So when you generate the model, there's a couple different ways to consider the haunch. One of them is by inputting the camber of the beam. So previously you could input the camber, but it didn't actually model a camber. Now, if you input the camber in OBM, it does model a camber, which is fun, I guess, but for the purposes of vertical clearance, right, you cannot take into account beam camber in FDOT. So you do have to make sure that if you are modeling the camber, and again, you don't have to, but if you are modeling the camber, you need to make sure that you're using that chord distance or chord line, I guess, to do the vertical clearance checks. So just keep that in mind. On the left, we have the NBent and pier report. So that goes through and gives you, again, all of the information that you could ever want to know about these NBents and piers. So it gives you cap information, so cap, lengths, station skews, elevations at the corners, and then it gives you all of the pile information for each individual pile, top and bottom elevations, the length, and then the northings and eastings. And then same for the piers, right? It'll give you everything from the cap, but also if there are footings, it'll also give you the footing elevation at the top and the bottom of the footings, as well as the columns. So the top left of the column, top right, and then top center, and then the bottom elevation, as well as the lengths of those columns. So there's a lot of good information there. I will say over the years, I've noticed some I guess some minor issues with some of those elevations, so just double check and make sure they align with the model itself. And then on the right, we've got the OBM quantities report. So there are a couple, you need to make, I guess, distinction between a couple different OBM quantities tools. So this, what I have the screenshot on the right is the OBM quantity report. So that's the built-in OBM report that comes with the software. There's also the FDOT automated bridge quantities tools. So I usually work them in tandem, right? So we'll use the FDOT automated bridge quantities tools, and then I'll also generate this, OBM quantity report and compare the two, make sure that everything is jiving, because there are still some kinks that are being worked out of the FDOT OBM quantity report. So again, I think it's good practice to compare those to each other. So anything that gets modeled in the bridge should make its way into this OBM quantities report. There are basically three main sections: the superstructure quantities, substructure quantities, and then miscellaneous quantities, where it throws things like bearings and barriers. All right, so I'll pause now and jump into a model, and we'll go through and take a look at some of these reports. So, like I mentioned, this is the training guide model that we're using here. Here's this. So this is a two-span fib bridge with obviously a two-column pier, and this one actually has a sidewalk in here as well, which is modeled using barrier tool. So this is, again, if you do the FDOT OBM training guide, this is a bridge model that you will end up with. It's got forward-facing cheek walls there as well. So I'll go through and, again, just use this as kind of as a demo. So I'll first take a look at the bridge or the alignment report. So this is the alignment. You can see this is a reference. So this is not something that we are expected to model. It's just a reference to roadways data, basically. So a couple ways you can access this geometry report. The easiest one is to click the alignment, hover over it, and then click this little paper clip here, and it pulls up the horizontal geometry report. The other way is in the Open Bridge Modeler workflow, the Civil tab. in this general tools, there's this drop down here for different reports. We've got our horizontal geometry report, and then the profile report is under there. So it's not really too much to this. This is the again, just all of the alignment information. So again, I would recommend that you put a box around the information that you are interested in. And again, you can see the units there. I think that there are ways that you can change the formatting here. Yeah, so you can update the precision within the report itself. But I believe that it also does follow whatever your design file settings are as well. So if I go through and change this, I believe that it would follow along in the report. Yeah, so I went through and changed my design file settings, and now you can see that everything is just in master units and decimal to 3 decimal places. So that's the horizontal report. You could also open up the, you can see that this is just a 2D line, right? There's no 3D component to it. And that's because we only have the default model on. So the default 3D is the actual like profile that's projected up from the alignment, but the profile doesn't really have any data in it. So that's why we generally just turn it off. But what you can do is you can hover over the alignment again, and then you can go to open profile model. And then down at the bottom, the view groups, you could go, I usually just go to 8. And then, so this is just a spare view so that you can keep this view in the main one. And then you just left click in here, and it'll open up your profile. So this is, again, the profile that is associated with this alignment. So you can follow along on the profile wherever the bridge is located. So once you have this profile, this is, again, another way you can access a profile report. Hover over that profile, again, paperclip profile report, and then it'll do the same thing. It'll open up this vertical, they call it the vertical alignment review report, and it'll give you all of your vertical curve information here for, again, the whole alignment there. So that is the civil geometry reports. There's also a super elevation report. So I think that we did have a super elevation model on here. I won't get, I guess, too detailed into that. That was a 3D one. This super elevation shape is how you can easily apply super elevation transitions to a bridge. So you can set your bridge template, and then you can basically say, hey, I want my bridge to follow along this super elevation here. So you can also go through and generate a super elevation report based on this super elevation shape, which can control your deck super elevation. So that's another report that you can take a look at. So now let's look at the OBM input report. So the OBM input report will be in the OpenBridge Modeler workflow, reports and drawings. We've got all of these reports that we just talked about right here. So I'm not going to spend too much time digging into all of these reports. I just wanted to make you aware of where they are generated, and we'll just scroll through several of them real quick. So you can, if you had multiple bridges, you could select which bridge, which unit, and then you can choose what report options are included. Just click all, and then you can adjust the accuracy here, hit submit, and it'll go through and it'll pull. Again, this is a report that generates all of the, or echoes all of the information that you put into the bridge model. So it should be, I believe, around that 39 pages, looks like 40 pages. So again, just all of the support line information, all of the variable constraints for all of the different deck elements that we have, and we have several different deck sections here. It's got our indent information. Again, everything that you put into OBM, it echoes back to you. So, you know, our beam layouts, how we define our beams geometrically, how we define our beams physically in terms of the template that's used. Here we've got a fib 84. It also shows the material that we assigned to it. Can keep scrolling through. Again, it's got, barrier. It shows what the name of the element is, what the material is, what controlling support lines are there, whether we've told it to have a skew or whether we've told it to have that break back. So a lot of really good information. This is the main thing, along with the checklist that we'll go through and use and highlight as we're going in and interrogating the model and checking it, making sure that everything is correct. So we're at the end vent area here. It tells you the name of the template, right, that's used in there, so you can locate that template and you can jump into the template itself, check it out, double check the geometry, that everything makes sense, and again it does echo all of the materials that are applied, as well as all the column information and everything. So a lot of good information in this report. The deck elevation report here, you do have to go through and select your start limit line and your end limit line. So I'll just select the front face of back wall and the front face of back wall, accept or reject. So left click to accept. And then this deck elevation report gets generated here. So these are just the start and end lines that we just selected. If you needed to have an offset for one of those lines, you could do that. You could enter that here. And then the report type. This is what I was talking about with several different formatting options. So consolidated is the one that is the closest to our finished grade elevations. And then you can see T lines here. There are two options. You can have it parallel to start support, or you can have it normal to the alignment. So those follow along with the FDOT options depending on your bridge geometry, your skew and everything. So you can go through and set those. And then you can set number of points per span. So just, you have to go through and make sure that you're following the SCM requirements in terms of the spacing of the T lines, making sure they're not more than 10 feet. So you could either do that by setting the number of points per span, or you can actually go in and you can key in the spacing of those T lines themselves. So those are your options. I'll just let it be 10 for now. Obviously, you'd want to check if you were using this. And then you go in for your references and you click which longitudinal points you would like to show up on that report. So this is where naming your elements is very helpful, because the name of the element is right here. So we can do, our left deck edge, right deck edge. So that would be our copings. And then, I don't really need to do all of these, but you can go through and know which barrier is which, right? So barrier 1 is on the left. So for barrier 1, I would want to do the right edge of barrier 1, because that's your gutter line. And then this is, I would assume barrier 2. So I'll do barrier 2. I want the left edge. And what you can do is you can click generate, and it'll actually give you these T lines, and it'll give you the points. So you can see we got our gutter line and our coping good over there, gutter line and coping over there. And then these are the points along our alignment. So it does go through and give you these kind of like temporary lines. So, sometimes we'll draw our T lines manually, and then we'll use OBM to generate, and then we'll see how they compare to each other. But you can see that this is the kind of the deck elevation report that gets generated from all of those T lines. So you can save this off as a spreadsheet. And then those will become actual numerical values or cells. And then you can set up a spreadsheet that compares, if you're using this to check. I just set up a spreadsheet that compares this with the calculated values, and then has conditional formatting to highlight any cells that are off by an acceptable tolerance, I guess, with the precision that we have. So you can also save and close this. So the temporary lines disappear, but they actually are saved in the model and they still exist. So you can actually drill down and find them here in the report section. So I can always bring this report back up, or I could also just display the decorations. So right click, display decorations, and it'll bring back those kind of ghosted in T lines, which are easier to see if you have wireframe on. But you could do that, and you could also open up this report again. If you made a mistake or you needed to increase the number of points per span, you could go through and do that, regenerate it, and then it'll save that that updated version if you save it and close it. So that should be good for that beam report. So I'm not going to go through the other ones in the interest of time, but beam report is here. You can also do a bearing report if you want. That one I don't use as much. And then the pier report here will be a report for the abutment as well as the pier and the wing walls. So I will jump back into the presentation now. I think that I covered. Oh, the OBM quantities report. Let me just touch on that one real quick. So the OBM quantity report, you can have it include cost data if you would like, but I will say in the FDOT workspace, we've gone in and zeroed out the cost of all of the materials, and that is because we want the starting point to be zero if people want to go in and assign those unit prices based on either the the BDR cost estimating chapter, or if they have if they're using historical costs or whatever. We want people to be able to enter that on their own. So starting point is zero, but again, we could enter in unit prices within the material library, and then this would have the associated unit price, quantity, and then it'll get you at the end of the day your total cost, and then you could calculate your your cost per square foot. It's very helpful for evaluating BDR options, right? It's a really quick way to evaluate several different options and compare the costs. But again, the quantities is broken down into superstructure, substructure, and then miscellaneous here. And then if you had costs, it would give you a nice little pie chart about where the proportion of each cost is coming from in terms of the components. So very helpful tool. The cost information is in the, if you go in the utilities tab in the library here where it says material. This has some structural properties. It has some like unit weight, Poisson ratio, concrete strength built into all of these materials, but it also has this unit price here. So you could go in and you can modify this unit price, and this is saved on a per project basis. So changing this only changes it for the given project that you're working on. So the work set that you're working in OBM. All right. Back to the presentation. So we talked about this already. This is outlined in the checklist, but of course you want to make sure that the model is based on the design, or the design is based on the model, however you want to think about it. And you also want to make sure that the design and the model meet the FDOT requirements, same as you would do with a 2D design, right? So part of checking the model is checking the geometry, unless there's been a standalone check and confirmation of the geometry. But we want to make sure, again, that we're meeting all of the FDOT requirements. All right, so I mentioned it before, and I'll mention it again. So model review that we do within OBM, you don't need to know how to create a model to QC one, right? So this model, once it's created, is just geometry. So I don't need to know how to go through and model each of these elements because they're there. They're on the screen already. I can zoom in, I can measure them, I can interrogate them, and I don't need to know how to create them to do that. At this point, it's just a 3D element. So what you do need to know how to do is to navigate around in the model and how to access all of the information that's stored. So I'm moving past the documentation phase of the presentation or the topic and moving into the actual getting into the model, reviewing it, and some kind of like tools that we can use to help navigate around and figure out what it is that we're looking at. So similarly to before, I'm going to go through these lecture slides, and then I will go into that same OBM model, and I will show you guys how to navigate around, get some of this information that we can use as a part of the QC. So let me go to the next slide here. All right, so again, a live demo will be very helpful once I get there, but let me just give you the kind of the background first. So the first thing I want to talk about is level management. So level management would be you go in and you turn off the elements that you're not currently working with. So you can use just a 2D line work if you want. You could, if you just want plan view dimensions, you could go through and you can turn off all of the levels that are 3D. So in OBM or in the FDOT workspace, all of the 2D levels start with the word decor. So they're all grouped together in the for the levels, for level display. So if I wanted to turn them all off, I have them all in one area here. If I wanted to turn off everything except these decor, and you can see it also has 2D in parentheses at the end. If I want to turn off everything besides that, I could just go outside that and get rid of all of the other levels. So that makes it easier. Once you are going in and navigating and measuring things, you can either make sure you're not snapping to something that's that doesn't have any elevation component, or you can make sure that you're only snapping to 2D line work if that's what you're looking for. If you're just trying to measure like a plan view, maybe you just want the 2D decor levels. So the middle element there, or the middle screenshot there, is the pop-up menu. So over the years, Steve has gone through and has perfected this pop-up menu and what tools are included in it. So basically, you can just go anywhere in the model and press the space bar, and this pop-up menu will appear. So it is it helps you get to commonly used tools and settings. And Steve could probably talk for 20 minutes about this, but I'll just give the short version, which is it's kind of grouped together. The tools are grouped together to make sense, right? You've got your Explorer, your FDOT create file is up here, your design file settings, some very commonly used tools that maybe require 3 clicks if you go through another method, but here you can just access it immediately. Got your analyze point tool, a lot of your measure tools here, and then some of your microstation, just classic microstation tools if you need to draw lines, rectangle, circles, all that. If you need to break lines, modify any attributes, and then there's some 3D tools here as well. So if you were doing some solids modifications, you could use some of these tools. This is a very helpful setting here, or tool, where you can rotate the view. We'll talk about that in a moment. And then these are some tools that are used for rebar modeling here. And then these are some of our plans production tools here, and some view tools down here. So you can modify this, or you can edit it if you want. If you've got some other tools that you feel that you use very often, this is something that can be modified by the user as well, but Steve's given us a great starting point for most of the commonly used tools so that we can save some time and work more efficiently. On the right here, this is how you can use view rotation, which is this tool right here. So you can use a top view to quickly get you back to like an unrotated top view, and you can use the ACS here to orient along an axis. You could use, for example, like I've done the 2D or top of footing, and then you could rotate around, which you can use Shift, right click, T for top, will get you back to your top view, or you could rotate around dynamically. So I'll jump into OBM and talk through just this view rotation, because I think it is very helpful, a very helpful tool for people when they're first learning how to navigate around. So let me move this back to wireframe here, and I'm just going to delete these. So we have our wireframe view, and it is a 3D view, right? So if I didn't want to look at either the, I guess we'll say I don't want to look at the 3D stuff right now. So I can go in and I can unhighlight all of the 3D, keep everything that says decor, and then I don't really need to mention, so go back and say that I don't want any of this. So now you can see that I only have my 2D information here. So I'll go Shift, right click, T for top, and it brings me back to my unrotated view. But if I wanted my view to be oriented with this pier here, there's a couple different ways. You can use R and then A as a shortcut to get here, or you can use, again, spacebar. Anywhere I press spacebar, centered on my cursor will be this pop-up menu, and then I could click this define ACS by points. So now I've got my ACS floating on my cursor here, and I could snap it. Obviously, what snaps you have turned on will control that, but I can snap it to the corner of the footing. So always look in the bottom left here, because it'll tell you what OBM is expecting of you. But you can see in the bottom left corner it says define ACS by points, enter first point at the X origin. So it wants me to define my ACS. So if I snap to the corner here, I've now defined the origin of my ACS. So now you can see the second click, it's rotating around depending on where I'm snapping, but it says enter second point on X-axis. So it wants me to define my X-axis. So I can just pick a point along this footing edge here. So I can click here. And now the last thing is it wants me to define the Y-axis. So now that we've set the X-axis, obviously the Y-axis could, in theory, be anywhere, in and out of the page or on the page. So we want to define it on the page here. So we want it to just be along the other axis of our footing. So now I can click on the axis of the footing, and now you can see the ACS has been defined here. And what that is helpful for is now, if I went Shift, right click, either hit T for top, or it's also up here for view rotation. If I click and hold, go down to top view. Now, when I do that view, it's going to have it oriented along the ACS. So that's really helpful if you want to, do some dimensioning, or you want to just, take a look at a particular element. And the reason it does that is because the ACS plane lock is on. So if that's a default setting now for us in the FDOT world, but if you had it off, this would not work. So that ACS plane lock needs to be on. So you can always go through and you can redefine this, or you can reset your ACS so it'll go back to basically north being oriented for your unrotated view. Okay, so I went through that. One more thing that I'll mention, so I'll turn back on all the 3D elements, just how to rotate around within the view here. So we already talked about the top view, how to quickly get you back to a top view, unrotated. So you can also do dynamic rotation. So you could, again, up here, click and hold. You could go to this rotate view, and it gives you this crosshair. So what this crosshair can be helpful for is to snap to an element. So say I wanted to rotate around this footing corner, I snap the crosshair there, and then with my left mouse, I could rotate around, but it'll always keep me, no matter where my mouse is, it'll always keep me rotating about that point. So that can be helpful. And then if you want, you can always move this and snap it to another point if I want to rotate around the cap there instead. Very helpful targeted rotation. You can also do dynamic rotation without the crosshairs, which you can do either click and hold, use rotate view, or what I generally do is hold shift and then use your click wheel, and that'll also give you a dynamic rotation there. You can also do a couple other views here. You can do a front view here to give you an elevation, which again, depending on how you have your ACS set, will control what that looks like. Do what is considered a right view, depending on the ACS. And then you could go to an isometric view. as well. So those are some of the view options there. So I think that was pretty much it for that. Let me jump back in the presentation. Try not to get too into the weeds here. So we'll talk about some measurement tools now. So when measuring in 3D, one of the biggest issues that comes up or could come up, cause confusion, is when you're measuring, because you might be snapping to a 3D point above and a 3D point below, and you're getting that diagonal distance, and maybe you didn't mean to. But there are ways to control against that, and there are ways to make sure that you kind of understand what you're clicking on. So one is level management that we just talked about. If you don't care about the 3D stuff, you can just turn it off. If you don't care about the 2D stuff, you can turn it off. And another is these options to flatten to file Z or flatten to view. You can use those. So these are your options here. So if I were to, you can see I measured the cap basically. So if I clicked this top point and this bottom point, you can see that the true actual 3D dimension is 3 feet. That's the depth of the cap here. But if I did flatten to file Z is, up and down. So it's going to be 0 basically. So if I measured from this corner to this one, that true dimension would give you whatever this diagonal is, but this flattened to Z would give you basically the plan view dimension of the width of the cap here. So it's important to kind of pay attention to these settings. If you're in a top view, you could also use flatten to view. That would give you the same thing as flatten to Z. If your ACS was oriented with the Z axis plumb to the world. So just some things to keep in mind. And these tools are just the normal microstation measurement tools. There's nothing magical about these. You just need to keep in mind the Z dimension. So again, if you're in top view here, you might notice that if you're snapping to 2 points at different, you might end up snapping to 2 points at 2 different elevations, which you can see happened here, right? So this says my true dimension is 11.294. Which if I look at that, I would have that red flag that's like, that footing is probably not 11.294 feet wide. So then you could take a look over to this flatten to Z and see, oh yeah, that makes more sense, 10, right? And something else that it gives you more information here is it gives you these Z elevations. So this actually tells you the elevation of the first point that you've clicked, and the elevation of the second point that you clicked, and the delta. So that would actually, in this case, give you the footing depth here. So it does give you a lot of good information. Also gives you the, I guess, the easting and the northing information as well. Yeah, so that's a lot of information there. Another thing that is helpful is to use the tentative snap to find elevations and easting and northing if needed. So let me just jump into the OBM model real quick and kind of show you what I am talking about for, let's see, do some measurements. So just do within points. I've got flattened to file Z, so I can grab this and grab this. Don't care really where it's snapping. I happen to get to the top elevation there, so you can see that I've got that elevation of that footing there. So that is a good way. And then also you can see that if I tentatively snap here, so with my settings, or I think the default settings, if you right click and left click, if you use those at the same time, it's like a tentative snap. And you can see that elevation here, if I go to Z, is 115.12. So if I tentative snap to the bottom here, it's 112.119. So that's a quick and easy way to just grab some elevations without really needing to use any tools. And like I said, it also gives you the easting and the northing. So if you can, I guess, use your XYZ coordinates to your advantage to just spot measure some points, and it's very helpful. So back into the presentation. Oh, yep, I already apparently I listed this out in the slide here. So you can see, like I just did in the model, if you tentatively snap to a corner, it'll give you your easting for your x value, your northing for your y value, and your z value would give you your elevation. So that is a very helpful option. So another tool that you have at your disposal is Analyze Point. So Analyze Point gives you all sorts of good information. So keep in mind that if you select an alignment, it will only give you the elevation of that alignment because alignments don't have any implied cross slope with them. So Analyze Point is very helpful. You can use it on alignments. You could also use it on terrains, but it'll give you, station offset information. It'll give you that same easting and northing. It'll tell you the Z on snap. It'll tell you the Z difference. So Z difference would be if I used Analyze Point on this alignment and then I snapped to something else like a terrain, it would tell me the Z or elevation difference between the alignment and that point that I'm selecting. And then it'll also give you the slope, the direction, and then radius if there is one. And you can also go in and place some text there or copy the clipboard or copy to clipboard at placement. So all of this information here can be basically placed in the model and or copied to a clipboard. So the way that you use that tool, let me go. I never actually know where it's at, so I always just type analyze, which is another, I guess, thing to mention. So there's a lot of different workflows and everything, and all these tools are in multiple different places, but you can always use this search ribbon. You can click F4 or type, or yeah, I guess select F4 on your keyboard, or you can just click up here and type, start to type any, I guess, tool within OBM. So if I start to type measure, all the measure options come up. Like I said, if I type point or analyze point, that tool will come up, and it'll also teach you where that tool is. So if I hover over it, it tells me that I can find it in the OpenBridge modeler workflow, civil group, general, or civil tab, general tools, civil analysis. So it can teach you where it's at. So civil, general tools, civil analysis, analyze point, there it is. So you to use Analyze Point, you always have to select an element. So like I said, either a terrain or an alignment. So now it's kind of snapped and guided along this alignment. And you can see this information is changing dynamically as I move along the alignment. So that is very helpful. Let me turn on this, I guess, terrain file real quick and show that we can do the same. Let me turn on the triangles, maybe. So you can do the same analyze points with either you can snap to the alignment and then snap to terrain. So it'll tell you that the terrain information in respect or with respect to the alignment, or you can also select the terrain itself as the element, and you can go through and kind of take a look. These ghosted in lines are the contours, but you can go in and you can get elevations at all these terrains. So where this is helpful is when you're checking your footing elevations or when you're developing your footing elevations, you can check what the terrain is at several of these locations at key points in the footing, and then that'll help you determine your footing elevations. So that is that. Let me turn this off for now. All right, back to the slideshow. All right, another helpful tool is the civil labeler tool. You can use that to, again, quickly label points. So you can and should use it for the begin and end bridge and piers. So when you're doing plans production with model-centric plans, you don't have to key in that information. You can use the can and should use the civil labeler with these predefined labels that will have the proper dimension, the proper dimension styles and text, and it'll also have these fields in there already, so that wherever you snap to, it will have that information already populated automatically. And if this were a support line, you would snap it to the support line, and then if that support line changed or shifted, this text would dynamically update with that data. So that is a very helpful tool. You can use it for walls. You can use it for intersecting alignments. So everything's dynamic. So if you set everything up properly, it will help with any changes that are made. Another option or another tool is Label Terrain Spot, which is a new one that I haven't used much yet, but is very popular. Well, I guess I shouldn't have turned this off. So. Oops. Turn the triangles back on, and then see if I can label terrain spot. So you can go through and you can select your text style, and you can basically use it to go through and dynamically label terrain elevations. So you can select it here and oops, let me see. Try that again. Terrain spot. Oh, there's no terrain model selected. Try that again. There we go. Okay, so you select that. Oh, it's not coming through right now. Well, if it was working, you would select an element and then it would label the elevation here, and this elevation label stays placed after you, I guess, navigate away from it. But I am obviously doing something wrong. Like I said, I've not really used this tool that much. Steve mentioned it to me recently. It's probably because this is not an elevation type. Maybe, yep, there it is. Okay, so select the proper text style and dimension style, and then you will get the elevation. So again, you can go through and label at any point, and it's very helpful. And it doesn't have to be just on the triangle. It can be like in the middle of the triangle as well. So very helpful there. Get rid of all those. All right, another tool is the cross section, open cross section view. So this you can set the interval, and you can click through those intervals. So this is how roadway can navigate through their cross sections quickly at whatever station intervals. You can also key in specific stations as well. So it's helpful to get an idea of profile variation, haunch variation, etc. We used this in the case of a redecking that we modeled to assess the haunch variation. So we used the surveyed beams and the best fit roadway profile that they put together and compare it against the design haunch. So we then used it to refine the profile for that redecking and reduce the haunch that was going to be put on existing beams. So it is a pretty helpful tool. I'm not taking, I guess, too much time going through and doing these, but I'll use this tool as well real quick. Open cross section view up here, so it's in the civil tab in the cross section group here. Open cross section view, and then locate the alignment, and then you can define your left offset, right offset. Station we'll just pick in the middle of this span, and then intervals right now it's 5 every 5 feet, which is fine. And then can go into another profile or another view, select the open view, and now we've got our bridge model section view, and we have the terrain there as well. So you can go through and, oops, use again, center backbone, and then you can click through and see kind of how that terrain varies, how the profile varies, how the haunch varies, and you can just click through however many feet. You can see eventually the piers will show up, but again, you can kind of you can key in different stations if you want. That's not a station where a bridge is, but you can key in different stations, and it'll navigate to those points. So another thing that you can do is review the element properties. So this is very powerful within OBM, because as we go through and model these bridges, there's a ton of metadata that is attached to them. So if you just click on an element and you open the properties window, you can drill down so at the top, there's a wrapper level that goes through and basically groups everything. So if I select this pier here, you can see it selects the entire pier, the cap, column, footing. Like I said, you could drill down and find all this information. But if I were to turn off this, if you hover over it, it says comp group substructure. So if I turn off comp group substructure, that's the wrapper level. So now I'm just selecting individual elements rather than selecting like the entire pier. So that's just kind of a, I guess, a heads up of how it works. So these comp groups, it's the same thing for beams. The beam comp group is the beam and the haunch. So if you were to turn that off, you could then just select the beam individually. So that's kind of what was done on the right here. I turned off the comp group and I just selected the cap here. So then you can see the cap elevation and all of this, really good information. Tells you the cap type, the length, width, height. In this case, the cap and the back wall are one element, so it gives you the back wall information as well. So again, that wrapper level is not a physical level that you see. It's just used to group all of this together. So I generally will select the full element and then just drill down in the properties window to whatever element I'm interested in looking at. So now I'll talk about feature definitions and pay items. So having a material applied to each element is vital to the FDOT automated quantities workflow. So if there is no material assigned, no quantity will get generated. So that is very important that when the elements are placed, this material is defined here, because these you can see these FDOT materials have the pay item in them, and that is what is used with the lookup table to generate those FDOT quantities. So in this case, you can see this is when I'm defining, and if you miss it at the beginning, you can always go back and define it afterward. But you go through, you click it in the material area, you define all of the different materials for the element. So when you first place the element, you select the feature definition, and then that's, the feature definition would be end bent with concrete piles, and then that tells OBM what the element is, end bent with concrete piles, and it controls how the element is displayed, levels, but it also controls the metadata that gets attached. So once you select the materials for the entire element, then when you drill down for the cap, again, for this example, you can see that there's this what's called an item type called FDOT quantity abutment cap. So you can see that it takes that material, which is grayed out now because we're not editing it, we're just viewing it, and it pulls all of the information that gets reported onto the EQR. So this info will be extracted in the bridge FDOT automated quantities workflow. So it's got the description, it's got the proper units, the quantity in those units, the location, bridge number, so all that information that gets pulled and reported on the EQR. As always, the engineers are responsible for taking ownership of all model aided quantities. So it should, of course, be used as a tool and not as a crutch, right? We always want to make sure that we verify all of the information that comes through from the model and not just accept it blindly, because that's when you get into trouble for sure. So let's see, moving on to the next, we'll talk a little bit about concurrence with other disciplines and models. So one of the biggest advantages to model-centric workflow is interdisciplinary coordination. You can reference in other discipline models and perform both, qualitative and quantitative assessments for concurrence and conflict identification. So what does that mean? So we can go through and we can do the visual inspection that we talked about earlier. We can take a look at, roadway, drainage, lighting if modeled, ITS, utility, all of those elements, and we can visually see how they fit within the bridge model, or see how the bridge model fits within them. And we can also do measurements, right? So we can use various different tools. We can use clash detection to help identify, hard clashes, direct conflicts, or soft clashes, like I mentioned earlier, within X feet. So it's helpful for seeing if you've got utilities that you may not have that high level of confidence in the SUE, and you can flag anything within a few feet. So that's a very helpful tool. Not going to demo that one today. We're instead going to do a demo of how we would do a vertical clearance check for a bridge. But other things that you want to take a look at, obviously, are any survey of existing structures, if around. That's important, and how it relates to the bridge, proposed bridge. Take a look at bridge-mounted elements, if applicable. Sometimes we model the light pole pedestals on bridges. Sometimes we don't. Just depends how your model element breakdown or workbook looks. And then again, bridge phasing if needed for TCP. And I'll open up the model element breakdown spreadsheet if I have time at the end here. So yeah, so the next thing we'll talk about is vertical clearance check. So we're gonna be working with Bentley to potentially improve their clash detection tool, because you can use clash detection to do some vertical clearance checks, but there are some limitations. One is that it gives you a temporary view of that clash, which that represents a clearance, which is not, I mean, it's helpful in the moment, but sometimes you want to have a record of that. Another thing is it's not plumb to the world, right? It's just the true minimum distance between. And then the other is that the information is reported in latitude and longitude, which is not generally super helpful for us, because we don't usually work in latitude and longitude, and it's kind of a pain to convert. The other thing is that you select the levels, which can be harder to work with for like terrain files if everything is on the same level. You don't want to obviously pull the top top of a barrier when doing vertical clearance. So we want to filter out that that data, which we'll do in the demo. So what we're going to use is a more manual approach using just the microstation minimum between measurement tool. So this is slightly, I guess, different depending on whether you are using an existing terrain or whether you are using a proposed roadway model underneath. If you, in this example, we're going to be using an existing terrain. So this is if we're putting a bridge over an existing roadway and we're not doing anything to that roadway. If you had proposed roadway model, you would then just have to make sure that you have a terrain file extracted from the roadway model. So I've been told that that is a setting that can be enabled when roadway does their models to have a terrain file created, basically a surface or a terrain file created from the surface of the roadway. So again, that's just something to keep in mind, whether you are using this method to do the clearance check for an existing or a proposed. So I'll go through the, I guess, a process, I guess, verbally, and then I'll jump into the model and try to run through a demo. So you start by clipping the terrain file for just the area of interest. Again, if you've got barriers off to the side, you don't want to do that or have those shown, because then if you did minimum between, it's going to take from the top of the barrier to the bottom of the beam, which is obviously not the type of clearance that we are interested in. So after that, you'll likely have some 2D line work in the survey file that will represent gutter lines. So you can use those gutter lines and clip out everything outside of those limits. And then within the civil tab, there's a model terrain group. We'll basically go through and we'll clip that terrain based on a 2D element that we've selected. And then once we clip that out, we can then use this measure between, which will again consider the entire terrain, but it will only consider one beam at a time. So we'll go through and check the individual beams, find out what the controlling one, and that min between does give you that straight line distance like clash detection, but you can use the top and bottom points and compare the 2 points and select the controlling one. So let me jump into the model. And let me actually, I think this is the end of my portion, so let me close this out. After the break, we will, I'll hand it over to Steve, and then he'll talk about model-centric plans, tips and tricks. So I'll do this, and then I think I should have time to talk about the model element breakdown. So depending on how cleanly this goes. So let me turn back on my survey here. And I guess just for your guys' information, sometimes we don't have the triangles turned on. So this is a reference to a survey file. So we don't own this file, so we don't really control how it's displayed. But what we can do is if you select the terrain in the properties, you can see that there's an option at the bottom here, or I guess not the very bottom, but it's called reference. And it says override symbology. So by default, it's set to no. But if I change it to yes, you can see that all of these elements become available to change. So before, they're just going to be set based on whatever the controlling file settings are. So I will go ahead and rather than have the triangles off, I'll turn them on so that I can take a look at that terrain. So you can see here that this terrain shows, that we've got an adjacent bridge here that's got a slope down here, and that's the I guess the existing bridge. And you can see that we've got whatever this original roadway alignment was, which obviously needed to change for this bridge to be constructed. but what we're going to be using is just the roadway portion here, and we'll use that in our vertical clearance checks. So let me see. So I'll go through and create a just like a 2D element to clip this terrain. So I'm not going to be I won't be incredibly careful right now about I should use the pop-up menu. I won't be incredibly careful about the limits that I'm using. Obviously, when you use this in practice, you're going to want to actually use a like the proper lines, right? So I'm just gonna, for now, I'll just say that this is I'll just say that these are my gutter lines. They're not, but I'll pretend that these are my gutter lines for the purpose of our demo here. Okay, so I'll place I'll just place a shape here. So I'm gonna just use this. Again, pretending these are my gutter lines, figure out what your actual gutter lines are when you're doing this, but in the area under the bridge, you can snap to our, oh, this is not gonna, let me shift this over. This is gonna be where the barrier is. All right, let's try that again. These are our gutter lines, we're gonna say. And then I'm using these lines because they're 0 elevation. Otherwise, you can key in 0 for your Z dimension, and you'll make sure that you're not snapping to something that's 3D in space. So we've got this this shape here. So now that we've got our shape, we can clip the terrain. So OpenBridge Modeler, Civil Terrain Model. Create clipped terrain model. Where are we at? Create clipped terrain model. So select this option. The reference terrain model is just the only one that's in there, the serve RD. So we'll use clipping method external, I believe. So it'll clip everything outside of this shape. And then you can use a feature definition just because that's the proper practice. And then it wants you to locate the clipping element, which I've already got selected. And then I'll reset or right click when done. And no offset, clip external. And now it should have a clipped terrain. So a copy of the clipped terrain. So now you can see I've turned off my terrain file, but I still have this this terrain, this basically clipped terrain. So it makes a copy of the terrain using these clipped boundaries that I defined based on my fake gutter lines to help us isolate the area that we are interested in for our vertical clearance check. So now that we've done that, we can use our minimum between. So if I just go to measure distance and then use minimum between, I can select the, so we'll just do this outside beam first. So again, it uses the entire terrain, but when you're clicking the beam element, it just uses one beam. So I'll click this beam and I'll click this terrain and you can see 18.111. So you can go through and check a couple different spots, 17.917, so we can see that's less, and then 17.785, even less, so that's telling me that this other side is going to be the one that likely controls. So use this beam, select this terrain, 17.626, so that looks good. Right, so these are, this is our point here. So what you can do is you can now, this is an element that you could actually snap to. So you could either, you can draw a line here, or you can just place circles at the end. So I'll just do a line so that we keep it for now. So even if I did, minimum between somewhere else, I could trace this line and this is my, my clearance. So, yeah, we can, let me just put like a little circle here. So I'll put a circle at the top and a circle at the bottom. And again, this is not plumb to the world. This is just minimum between. So now we've got our circles defined there. So now that we have this straight line distance, similar to what you would do in clash detection, but you can use, again, the top and bottom to compare those 2 points. Let me see. So now we can use the cross section tool. We can get the stations for this these points. We can use a cross section, or I guess we'll use section call out, so it's like an actual drawing, and we can snap to these points, use that cross section tool, and then we can measure there. So let me do drawing, annotate. So this section call out tool. So we didn't really talk about this too much or at all, I guess, today, but this is a tool that you can use to generate all sorts of different plans. You can use it for your typical section, you can use it for your pier. We're not going to use it for plans necessarily, although you can use it for exhibits. But we will go ahead and use it for, I guess I'll just do solid, to give us a view of what the clearance looks like at these points. So I've selected my drawing seed, and then you can just do a point here. I'm just going to kind of just select it, I don't say randomly, but it doesn't really matter because we've got this point included, and that's sort of the point here. So I'm going to do, let me just do vertical clearance 1. We don't need a sheet model really because we're not creating, not really worried about an exhibit, but just pick a scale, and then it's going to create this section. So if I click OK, it should go through, create this clipped volume here, and then do like a saved view, and it'll create a drawing model with this section, and then within that drawing model, we'll be able to measure and do a dimension to this this point that we are interested in. So you can actually see that the line is there still, that like non-plotting element. So this pops into another view here. So if another model rather. So if I go back to the default model and let me go back to wireframe, I still have this this drawing identifier here. So I'm just going to get rid of the front depth and the back depth because I just want a section. I'm not worried about depth. And then I can use this handle if I want to pull it past this area of interest, or I could use the width as well, but pull this handle outside here. Let's not have it face that way. Flip direction. Okay, so now that I've adjusted that, you can see it's still going through our point of interest. But if I go back to our model, you can see now that it's got a better view of the whole bridge. So you can then go through and, you know, this is the controlling point. So you can do just, you know, you can do minimum between again if you want. And then you can do like a dimension. FDOT structures, that. And then we can say that's our vertical clearance, 17, 7 5/8. So that is the one location. So you can go through and do that again to this other location here. Snap there. Again, the angle doesn't necessarily matter because we've got the point already. We'll call this vertical clearance 2. the same. We don't need a sheet, so it's going to create now just another drawing model here. So we now have VC1, VC2. I'll go back to the default model and make those same adjustments. We don't need any depth to this section call out. Here, just have it be 0. And then again, we don't necessarily want it to end right there. We can have it continue. So we'll pull this out, keeps flipping that on me. Right click, flip direction, just so I don't get disoriented. Go back to view 2. Now we've got our nice view here. You can see that it was the bottom point here is the one that was controlling. So I could just snap to the middle here, but let's do our minimum between again. There to here. So this is our minimum between. And then we can do our dimension again. Snap to there. Oops. Snap to there. Snap to here. You can see this is 7 and 7/16. So 7 and 7/16 versus 7 and 5/8. So we'll go with the one that is less. So this is 10/16, so 7/16 is less. So this is our controlling vertical clearance. And what you can do with this is create, like I said, for your documentation, you can go through and create a graphic, and let's see. You can create a graphic like this, where you've got your PMVC for the left bridge. You can use civil labels to give the station and offset of that location, and then the same if you had a right bridge, station and offset of that location. And again, you could go through and you can use different tools that give you actual dynamic information from these sections. You can get elevation, and then you can give the dimension for these two locations. And this is a great tool, again, to do vertical clearances. It's super accurate and a lot easier than trying to guess sometimes and check various points depending on the longitudinal grade and the cross slope of the bridge as it relates to the longitudinal grade and the cross slope of the roadway underneath. Very powerful, takes the guesswork out of it. Okay, so that is it for the vertical clearance demo. So now I'll take a look at the model element breakdown. So kind of going backwards with our OBM QC checklist. So we'll do FDOT CAD manual. Then documents and publications, 2025 CAD manual. And then within the CAD manual, I don't know what section, but if I search for model element breakdown, so 5.16.7, or page 5-31, it mentions this model element breakdown workbook. So we've mentioned this in several trainings. So if you've taken trainings with Steve and I in the past, we probably mentioned it. But this model element breakdown spreadsheet, I'll navigate to the structures. This can be used for several things, right? So the I guess the intent maybe, or the initial intent is for scoping, right? So if you are doing either scoping or negotiations, this helps everybody be on the same page in terms of what the expectations are for the model. So if there are, really detailed elements that are important for whatever reason, and you want them modeled to a higher level of detail, or whether maybe you don't need them in 3D, or maybe you just want the model or the element in 2D. So what is in here by default is considered kind of a standard level of detail and standard expectations for 2D and 3D bridge elements. But the idea is not for this to just be taken and copied forward. The idea is to go through and have this be a more of a living document, have it be edited, have everybody who's involved on the design side, the DOT side at the district level, know what we want, what the expectations are, and then obviously that can be used as a scoping tool, basically. So this has tabs for all the different disciplines. Walls are within the roadway tab because they use the ORD tools, but it goes through and talks about in these other tabs level of detail, right? So if you're not really familiar with the level of detail and what that means, it goes through and defines them here. And there's also some graphical examples. It uses a drainage element, I think, as an example, but you can see 100 is very, very low level, 200 is, 2D, 300 is getting into 3D, more or less size, shape, location, orientation can be measured, can measure interference, but then when you jump to like 400, that's when you start to get even more detailed. You've got the rebar modeled in there. It's, most of the time we're living in like 300. So I would say most of our models are more 300. Then there's 400, and then 500 is basically, contract as legal document. You could construct this bridge with this model. So 500 is the goal eventually, but for now we are very much living in the 300 to 400, sometimes we call it 350, level of detail there. It's also helpful to talk about some of the BIM uses. This tab could probably be revised a little bit, but what is the purpose of BIM, of doing these bridge models and roadway models? Are we just concerned about interdisciplinary coordination? Do we need to step it up? Are we using it for construction? Are we using it for construction estimates, inspections, layout, potentially automated machine guidance, constructability reviews? And then the next level up is, are we trying to do digital as-built from it? Are we potentially using the model to generate shop drawings? Are we using 4D, 5D budget or scheduling? Oh, sorry, I was misreading this. The information is to the left here. So level 1 is visualization quantities. Level 2, interdisciplinary. Level 3, constructability. And then level 4 is the 4D, 5D digital as-built and fabrication shop drawings. So this helps all of the stakeholders kind of get on the same page about what it is that they're looking for from the model. So I think it's very helpful to discuss these BIM uses again amongst all the stakeholders and players there. So I believe that is everything that I have. So I will open it up to any questions about I guess model QC that we just went over, and then after questions we'll go for a 10 to 15 maybe 20, we'll see, minute break, and then we'll come back and we'll talk about the model-centric plans, tips and tricks. So any questions at all about what we went over? I'll say I'm also not super familiar with GoToMeeting, but I'll let Brian drive if there's anything. But if not, we can either do questions at the end, or we can just go directly to break if everybody is all OBM'd out in the last couple hours.
No, I think that's a really great job. I'm here. I don't see any questions. If there are any questions, feel free to put them in the questions dialog box or the chat. But I don't see any indication right now of any questions. And Heather, like you said, we can take questions at the end if you would like, if we'd just rather take a break.
Sure. Yeah, let's go ahead and do that. Maybe during the break, I might throw together a poll, or Steve, I'll message you if maybe you want to throw together a poll about attendees. I know we've done that in the past to try to understand what everybody's role is, so I might do that during the break. So it is like about 10:15 now, so let's come back at like, I don't know, 10:30-ish, and we'll probably get started maybe 10:35, a few minutes after, so about 15 to 20-ish minute break.
Sounds like a plan. Really quick, Steve and Heather, do not end the webcast, please. Yeah, just leave it how it's set, and we can come back to it. If you end it, it's over.
All right, I won't do that.
It's all good. All right, we'll see you around 10:30.
All right, thanks.
We got your screen. Good to go.
Perfect. All right, let me make sure the right slide goes over there. Still able to see me and hear, or hear me and see the main slide?
Yes, sir.
Perfect. All right. So topic 2 is going to be model-centric plans, tips, and tricks. What are we covering in this part? We're going to talk about plans, production requirements, kind of give a little background on what is technically required, what is suggested. Sometimes there's some confusion over that. Some people have some misconceptions of what's actually required, so we'll go through that. We're going to go into obviously model-centric plans and what does that mean. So we're going to cover some key terms. We're going to look at the 2D traditional plans production workflow versus the 3D new model-centric workflow, what the key differences are between those two. And then we'll kind of cover really quickly some tools that are used in model-centric plans. Section callout is probably one of the main ones that Heather showed earlier. We do use that in a lot of different applications. Probably the second most used one is the name boundary tool. So we'll cover that one here too. We'll give some general recommendations on when to use model-centric plans production versus just traditional 2D drawing plans production. And we'll kind of get some bonus tips and tricks in here with some display styles and some display rules, some things that some people might not be familiar with. So we already mentioned it before, but that CADD OBM training guide, everything that I'm going to cover here is going to be kind of an abbreviated overview of some of the exercises and the content in the training guide. We spend a lot of time and effort about 1.5 years, 2 years ago updating this manual. The data set, the bridge that it covers now is going to leave you much better, much more prepared for the real world applications than the previous one did. So highly recommend going through there. I put a link to where that's at in the chat earlier at the beginning of the presentation. And you can always do a Google search for it too. Just search for CADD OBM training guide and it'll be the first thing you see in that result. So highly recommend going and checking this out or referring to this if you have any questions about anything in the future. All right, so plans, production requirements. What do we actually have to do? So we did have the production support memo PSM 20-01, which was released back in, oh boy, I think it's back in like May of 2020, so about 5.5 years ago now. Not anything has changed since then. So kind of a couple key snippets from that memo. I'll just kind of read through it here. The memo outlines the department's adoption of Bentley's Open Bridge Modeler, OBM Connect Edition. This change is necessary due to Bentley's transition away from MicroStation GeoPact and Select Series Edition. So the keywords here are really Connect Edition, which technically Bentley, I don't know if they even use that anymore, but that's kind of what we still refer to it as the newer Bentley platform, and then the Select Series Edition. So they're not supporting the old Select Series stuff, the V8i MicroStation products anymore, GeoPact. So that's why we had to switch over to what their current one is, which is the Connect Edition ones. Another snippet here, all projects that begin the design phase on or after January 1st of 2021, which obviously we're past that point now, must use Bentley's Open Bridge Modeler Connect Edition and expanded F.Connect workspace. The use of OBM after the release of F.Connect workspace in July 2020 is encouraged. That was just a line to get people to say, you should start using it now, but we're going to require you to start using it in January 1st of 2021. And then there's one little, or actually 2 little sentences here at the very end of the memo that are really the key takeaway here. So the transition to Bentley's current civil software application, OBM, will not require bridge designs to be modeled. Structure plans can be developed and delivered as they currently are. So this means that you do not have to deliver a model, a bridge model, as a deliverable yet. You can. It's definitely well within your right. And we have language in the CAD manual of it. PMs within a district or districts as a whole, or anyone can, in charge of a product, they can put that in the RFP that models do need to be required. And talk a little bit about that later. But in terms of plans production, you can still draw things in 2D just like you always have. The only thing you have to do is use the current workspace, the current supported workspace for it. So that's kind of a misconception. A lot of times people think, oh, I have to do a model, I have to deliver it, and I have to produce plans from it, but not the case. All right, so some model-centric plan key terms. We're going to be throwing a lot of jargon around here, so I wanted to kind of talk through what each one of these are, and I'm going to spend a lot of time kind of going into the background of the more like the theory of the model-centric plans production workflow, because it's very different than our typical or traditional 2D workflow. And understanding how things work under the hood will help you troubleshoot when things go awry, which they almost always do since it's a Bentley product, but you'll be able to troubleshoot much faster and understand how they work and just kind of produce a better overall quality product in the end. So DGN, this has been around, this turns around for a long time, but you can kind of think of this as a container of models or a box of models. The DGN is not a model itself, it's just a container. Design model, this is going to be where the native geometry and elements are stored. Typically the black background color. 2D design models are what were used in the past for 2D plans production in the old school MicroStation V8i series. Clip volume, this is going to be used to define a specific volume within the 3D model that you wish to create a saved view of for placement into a drawing model. Clip volumes are automatically created when you use certain dynamic view workflow tools like the section callout tool or a couple other ones. And that basically, it's just used to define the region of the 3D model where you want to actually show a 2D view of. Save view, this is a view definition which includes level display, the clip volume, and other view attributes. Drawing model, this is one that we might not be too familiar with. We never used, or I shouldn't say never, we typically did not use drawing models or sheet models in the old school 2D plans production process, but they've been around for ages. I mean, they've been in the old V8i series, Select series microstations. We just never really used them. But a drawing model is used to get a 2D view of a 3D model by referencing a saved view into it. It's going to be where all dimensioning and annotations associated with that saved view are typically stored in that drawing model. Sheet model, now this is like the electronic or virtual plan sheet. It's a true, again, virtual size, 11 by 17, and drawing models are referenced into a sheet model for display on the final sheet. And we'll kind of show all these definitions again, or kind of go through them again in a better diagram that's more easy to kind of see and digest here in a bit. But first, we're going to look at just real quick one slide here on the traditional 2D plans production workflow. Typically, we would be drawing elements live in a 2D design model. We would be dimensioning and putting notes and things in that 2D design model. Then we just bring in a cell, like a border cell, and scale it up as needed. And then that border cell had like a little print area, like a certain level you can print. It knows the area to print, and then we would add that to a piece set and print from there. And that's kind of how we did the 2D plans production, right? Just mainly using the 2D design models with the black background. So what does the 3D model-centric, I call it the dynamic view workflow look like? Because really any of the even OBM, ORD, the 3D to 2D plans production workflow all uses the same process. It's the dynamic view workflow process. So we always start off with a 3D design model, again, that black background model, and we're going to be referencing in an OBM model. And again, I'm going to go over like a little chart here or diagram in a minute that kind of helps make this easier to visualize. But we're going to, once we have that OBM model and the design model, then we're going to utilize a dynamic view workflow tool, such as a section callout tool, to define a clip volume or a name boundary to control what of the 3D model you want to show. And in that process, you'll be creating a saved view. And then you're going to be referencing that saved view into a drawing model, and then referencing that drawing model into a sheet model. And then seeing how that reference scale, like when you reference that drawing model onto the sheet model, you might need to change the scale to make it bigger or smaller and see how it fits on the sheet. So you're going to be adjusting that scale and placement of the drawing model on the sheet model itself. And then once you know what the proper scale is you want for that drawing model that's referenced on your sheet model, then you can go back to your drawing model and make sure that the annotation scale in there matches what your reference scale is in your sheet model. And you can add your dimensions and your annotations to the drawing model. And then you go back to the sheet model and add any kind of generic notes or annotations to that sheet model that are not view specific, something like, C sheets B1-22 for reinforcing details or something like that. That kind of stuff would go in the sheet model itself. All right, so again, I'm going to kind of be regurgitating a lot of the same information, but kind of using different diagrams and ways of saying it to try to help it sink in, because it's, again, really important to understand the workflow and how it works to be able to really utilize all the tools properly for 3D model-centric plans production. But again, it's kind of visual here that DGN is the box or container models. And in a minute here, I'm going to show a chart in a couple slides that kind of goes over design models, drawing models, and sheet models. But again, just to reiterate, design model is going to be that black background. That's where the native geometry and elements are stored, where we use section cuts or different tools to produce the views. The drawing model is basically just used to get a 2D view of the 3D model by referencing in a saved view, and then dimensions and annotations associated with that view are going to be stored in there. And then we have that sheet model, that virtual 11x17. Another way you can kind of think of like the DGN and the picture above at the top there is like an Excel workbook, right? The Excel file itself has multiple tabs. And so the Excel file is kind of like the DGN, and the models are sort of like the tabs in the Excel file. Again, so different kind of way of looking at this. This is Bentley's little diagram that I kind of added some notes to for the dynamic view workflow. And just trying to reiterate the process here. So the design models, what we're starting with, that little symbol they show there. Actually, I'm gonna turn my little laser pointer here, make sure I can point at stuff here. They have a little section callout tool they're showing here. That's what they're kind of using this particular example here. So when you use that section callout tool, that's going to create a clip volume or a name boundary to show what of that model you want to actually get in the save view. And then it creates the save view, and then that save view gets referenced into a drawing model. And then the drawing model is going to be, again, a full scale, so 1-to-1. No, like if you measure things in a drawing model, they're going to measure actual real world dimensions. The annotation scale is going to be whatever is needed for when you reference it onto a sheet model. You don't necessarily know that until you reference the drawing model onto the sheet model. So that's why we kind of like to put the drawing model on the sheet models first, and then we'll go in and update that annotation scale. But it's just the reference of the save view in that drawing model. And again, we'll replace annotations and callouts relative to that specific view. And then the drawing model, we get referenced into a sheet model here. And again, the sheet model is going to be scaled as, or no scaling in there. The sheet model is a 1-to-1, real world 11x17, I guess you could kind of think of it. So annotation scale is 1-to-1 here. The reference of the drawing model, that's scaled down as needed to fit on the sheet, depending on what you're trying to show on the sheet and how many views you're trying to put on that particular sheet. And we do place some annotations, some callouts in the sheet model itself. Again, general ones that are not specific to a particular view. And then we'll kind of look at this in a more real world example here. So we've got 3 different examples kind of branched out here. The first one's going to be for something like this. This is going to be your single view on a sheet. So a typical section view, right? There's only one view shown on this particular sheet here. So that's going to be this left side here of this diagram. So we're always starting off with the 3D design models, or the DGM that has a 3D design model. And this is going to be your OBM model here. And if I want to create a typical section view, I would start off by creating a typical section DGN file. And in that DGN file, you have this 3D design model that doesn't have anything in it yet, but you're going to reference in your OBM model into that 3D design model of this typical section DGN here. Once you do that, then you can go ahead and do a section cut or whatever tool you want to use to create the view you need. And that's going to, again, create a saved view that gets referenced onto this typical section drawing model. That's all, again, contained within this DGN here. All these models here, there's technically 3 different models here, all contained within this one typical section DGN file. Drawing model is going to be where we have the dimensions and annotations relative to that specific view, and then we just reference that onto the sheet model, and we end up with something that looks like this here. So all of these dimensions here relative to this specific view, this would all go into the drawing model. Things like this down here that are some general notes and things that don't apply specifically to a part of the view, these can go in the sheet model itself. And the reason that we do that, or one of the main reasons I should say, is that if this section needs to get moved around on the sheets, when those annotations and everything are in the drawing model and you move the reference, everything moves with it. So it's really nice in that sense. All right, second example is going to be one where we have multiple views. Here we have like a footing detail sheet, so we got a plan view, section view of the column dowels going into the footing, and then like a front elevation view here. So going back to our diagram here, this is going to be the middle example. Again, we're going to start off by creating a footing details DGN file that has an empty 3D design model in it. I'll reference in my OBM model in there. And then I'll do 3 section cuts for what I want. I'll do a section cut for my footing plan view, a section cut for my footing elevation view, and then a section cut for the column, dowel view here. So 3 different section cuts that produce 3 different drawing models in the same DGN file here. And I'm going to put all my annotations for each one of these drawing models in each individual drawing model. And then one by one, I'll reference each one of those drawing models onto the sheet model here. Then the end product of that is going to be what you see here on this sheet. So that's kind of the middle ground in terms of complexity, I guess we're going to say that, for the 3D to 2D plans production process. Last example here is going to be one like this, where we have kind of like section cuts within section cuts. So we're going to use a view here, like a front elevation view, and then we want to cut through that front elevation view, which is a 2D drawing model. But we can do that because the program knows, when I create this view first, this front elevation view, it knows that it's created from a 3D model. So if I go into the drawing model of this front elevation view and do a section cut through it, it's going to create these sections for me here. And the reason I'm doing that is because I want those section cuts to go through my drawing model, because I want them to show up here. This is part of my plans production to show, okay, where is this section AA at? Where is the section BB at? I want those to show up in that drawing model, and I can do that. So what does that process look like? Again, same thing. We're going to start off with creating a peer DGN file, referencing in our OBM model into that design model within the peer DGN file, and doing 1 section cut to get my front, peer front elevation view here. And then I can put any of the annotations that I want for that particular view in there. But then within this drawing model itself, and as opposed to doing it in the design model, I'm going to do in the drawing model this time, I'm going to make 4 section cuts in this drawing model. I'm going to do a section cut, through the column 1, section cut 2 through the column. I'll do a cap section cut, and then like a peer side elevation view. So these are 4 different section cuts that I'm doing in this drawing model here. And then when I do that, it's going to create these separate drawing models here, which I can go and annotate and add dimensions, whatever I need, relative to those specific views. And then in the end of the process, I'm going to reference all 5 of these models, all of these gray drawing models you see here are all going to get referenced one by one into that sheet model and then moved around as needed and placed where I want on the sheets here to produce this particular plan sheet here. So those are kind of like the 3 different scenarios we typically run into to cover the majority of the sheets, you know, a single view sheet, a multi-view sheet, and then sort of a view within a view sheet scenario. All right, so the section callout tool is, like I mentioned earlier, probably one of the most popular tools. It's extremely versatile, lets us have a lot of control over what is displayed. So where is this tool at? This can be found in the drawing workflow. Let me turn my laser pointer again here so I can point out here. So the drawing workflow is up here. You might not be familiar with the term workflows, but it's sort of a new thing in this whole Connect Edition era. They didn't have these back in V8i or Select series. And all the workflow really is what am I focused on right now? What am I trying to do? Am I doing drawing, you know, plans production? If so, I want to use this drawing workflow. Am I doing OBM modeling? If so, then I'm going to change this workflow and drop down here to the OBM, OpenBridge Modeler workflow. And all it really boils down to is they have, you know, so many tools in all these different products now that they can't fit them all in one area. So they just kind of help organize them based on what it is you're doing. So when you change your workflow drop down here, it'll change all your ribbons here and all the tools within the ribbons to be based on whatever it is you're trying to do. So when we're doing plans production, we're typically in that drawing workflow here and in this annotate tab here. So under there is where this section callout tool is. Again, most of the time when you see a tool or something in MicroStation or OBM and ORD that's a lot bigger than the other tools, like this section callout button is a lot bigger than these other buttons here, that means that Bentley thinks that we're going to use this more than any other tool in this category here. And most of the time they're actually pretty spot on with that, and this is the case here with this one. So using that section callout tool, a lot of times, so like if we're going to try to create a pier front elevation view, like we were showing before, right? We're going to start out in a plan view of the model. So I'm in this black background 3D design model. I referenced in my bridge model. I turned off, you know, the deck and all the things I don't really want to see in this particular view. You know, save your settings because you always want to do that whenever you're manipulating the levels. And then I'm going to go ahead and get to a plan view. And the keyboard shortcut for that, like I think Heather mentioned before, was Shift right click T for top, or you can use the view controls to just use the rotate view and just go to a top view like that. So we'll be starting in a view like this top view here. And the next one, so when my first click is going to be my starting point for my section view here. And then my next click is going to be the end point for the section view, whatever it is I'm cutting through. And then the third click is going to be defining your depth of your cut. Now, sometimes we want to show depth, and sometimes it matters, and sometimes it doesn't matter. So you can always adjust this afterwards if need be. And then in order to do that, that adjustment, we can go ahead and like rotate to, so I'm just skipping this slide here. Actually, no, I'm just kidding. Okay, so once we do that section cut here, this tool is going to come up here, this dialog, this create drawing dialog tool. And it's kind of broken up into 3 pieces. And these 3 pieces are what we were talking about earlier, right? Save views is this first one here. So this is going to be the name of the saved view that it's creating for you. The seed it's using is based on whatever seed you choose when you first use that section callout tool. And then this second area here is going to be the drawing model, right, which the saved view gets referenced into that drawing model. In this case, I'm telling it, yes, go ahead and create the drawing model for me. I can take a guess at what the annotation scale needs to be initially, and I can always change it afterwards, that's fine. And then if I wanted to go ahead and create the sheet model for me automatically in this whole process, I can have it do that as well. Check this box here. And then I can, again, make sure that the scale, the detail scale I use, which is basically the reference scale of the drawing model onto the sheet model. We always want to make sure these two things match. And then go ahead and say open model and then click OK. And then once we do that, we're going to get something like this. So we'll have the sheet model there. We'll have the full pier drawing model referenced into the sheet model. But this is obviously not what I want or need necessarily for this particular sheet. We have to make some adjustments to it at this point. So how do we make those adjustments? Well, we can go back to the design model, and then in that view attributes up here, we can go to rotate view, and we can use the dynamic view, which Heather was kind of pointing out earlier, which has that little crosshair. I can snap that crosshair to a point on my pier and rotate it around. And then when I rotate it around, I can select that section call out, which is going to be down at elevation 00 most likely, assuming you didn't snap to anything with that section call out, or if you snap to the 2D decoration levels, which are always at elevation 0. I can click on that section call out tool, and then I get a nice visual of that clip volume. So when I say clip volume, this is what that is. This is what is containing the 3D elements and what I want to show in that 2D design model. So in this case, going back a slide here, I need to cut off these pile. I don't want to show 80-foot pile on my sheet model here. I can just cut these off somewhere below here, and that's what I want to show. I can move this whole pier down, and that'll be what I want. So the best way or easiest way to do that and grab these handles would be from like a front view. So you can do like a shift right click, F for front or S for side, and just get an easier view to manipulate the handles of the clip volume and know where those handles at, the boundaries at for that handle relative to the elements that you care about. So in this case, I want to cut those pile off, right around here. So I'm going to drag that handle up to this point here. And again, when you're in that kind of side or front view, you're just going to see like a line. Your section call out that is shown in this isometric view here just looks like a line in this front view. And you have all these different handles here that you can adjust to control what is shown in your drawing model. And then once we finish doing that, just adjust those handles there. Then we go back to our sheet model and our pile are cut off. So that looks good. You can just right click, hold, and move reference, since this is technically a reference, and move the reference down where you want it to be on your sheet model there. All right, place name boundary tool is going to be another one that we use very frequently. This can be used to generate a single or bulk plan views, profile views, or cross-section views. We mainly use it for plant elevation features, though. I would say we don't really mess with the cross-section. That one was made specifically for roadway and cutting bulk cross-sections and through their corridor models, and that's just not something that's really built for us and what we do. The example shown here is the plan and elevation sheet exercise from the CADD OBM training guide. We've already manually kind of turned off all the levels that we don't want to see in the P&E sheet here, but there's a cool trick to kind of show how to do that quickly later on. That's always going to be the first step, is to kind of get your level symbology the way you want it. Turn off the things you don't want to see before you do your name boundaries, before you start placing name boundaries. That's just the easiest way to do it. That way you don't have to go back and update things afterwards. So once you activate that tool, let's take kind of quick look at what we have up here. All the tools starting from this one with the little arrow here over, these were all the original kind of microstation name boundary tools. Now, again, the name boundary tool is an original microstation tool, and then the civil products, OBM and ORD, they kind of piggybacked off of that, and they made tweaks to it and made civil specific name boundary tools over here. So all these are going to be for like this normal 2D planche production. You can use these ones over here. But starting with this little line here and moving over, these are going to be all of the civil name boundary tools. So this first one here is going to be your civil plan name boundary tool. This one here, the profile, and then this one here is going to be the cross section. So in this dialog, there's a lot of drop downs, a lot of things to look at and be intimidated by. But again, we really go into excruciating detail on all these things in our training guide, so highly recommend going through all those. But we have this drawing seat here that we're going to choose. In this case here, it was like a 11 by 17 plan and elevation view plan drawing seed. It says 14-inch. So what is that 14-inch? That's basically the area that it's taking up or occupying on the sheet model. So there's a certain region within the border that we can put content on. And these last number here indicates the width of the area that'll take up on the sheet. Because sometimes we have, depending on the size of the bridge or depending on the scale we want to use, maybe we only want to put, occupy 2/3 of the top of a sheet for a plan view. Sometimes we want to take the full width because that just lends itself better in a particular bridge or particular job. So we have different seed files in here for that. I think we have like 11 through 15 or something like that, a bunch of different options here. So you can change these, and then this will change the size of the boundaries as you're placing them. Another thing that'll change the size of the boundaries is your detail scale here. You can choose any of the out-of-the-box detail scales. And really, you're kind of just going back and forth and playing with these two to see which combination works best for what you want to do in this case, your P&E sheet, or plan view P&E sheet. After time and after going through like the training guide, you'll get a good feel for what is going to work in most cases here. The 1 to 30 is a pretty common one for the plan view, and I'd say the 14 or even full width one is probably the most used one here. But you give your name boundary a name. You always want to put a number behind it because that's going to help when you have multiple name boundaries. Because this tool, the really nice thing about this tool is you can use this to cut all of your P&E sheets. So say you have 1,000-foot long bridge and you have 20 P&E sheets. You can just call this one Plan 1, and then it'll start cranking out and place out all of your boundaries for all of your P&E sheets. And it knows if you put this number in here to name the first one Plan 1, and then it'll automatically name the next one Plan 2, Plan 3, and so on and so forth. Then this is the group here. So this is basically like you have groups of name boundaries. In this case here, I'm just going to call this the plan group because all these name boundaries that I'm creating in this particular case belong to like a plan group. That's kind of what I'm using for. Then all these items down here, actually focus like on the length and the offsets and the overlap, things like this. These values here, really these four, the 420, the -75, and +75, these are controlled by these two things up here, the drawing seed and the detail scale. So the size of the area that you can occupy in the sheet and the detail scale here. These are what control these dimensions, and it maintains the aspect ratio of the seed files. So that rectangular area that we have in the seed files on the sheet model that I want to put this name boundary in or this plan view in, it'll maintain that aspect ratio so that you don't have to go and do those things manually. You can go in and adjust these if need be, but there really shouldn't be any scenarios, I don't think, where you're going to be having to mess with any of these things. Overlap, I would put overlap as 0 if I was doing match lines. You don't want if you don't want overlap and you just want to do straight up match lines, you can do that. Or if you put like 50-foot overlap, then what that'll do automatically is it'll overlap each name boundary by a total of 50 feet. So let's say if I put 50 in here, it'll extend the first name boundary the 25 feet past whatever the limit is, and it'll push the next name boundary 25 feet back for a total of 50. So that's how it gets the overlap. Boundary chords. So you can control the number of chords that make up the actual polygon element that is your boundary. If you're just doing a straight bridge, 1 would be fine. If you're doing a curve with a really tight radius, then you're going to want a lot more chords to be able to kind of chord around that curve and get a better depiction of the plan view that you're trying to create. In this case here, we're just kind of going through and doing the plan view first, and we're not generating any drawings yet. So I was unchecking this box here. Again, just following the FDOT training guide here. And then when you're first setting this up, once you get all these settings the way you want, you can kind of click on the alignments wherever you want the boundary to start. And then as you move your cursor ahead, this boundary will show up and appear here. And if I had zoomed out, and if I had a lot more boundaries I wanted to create, I can keep moving my cursor to the right, and it'll keep on creating those boundaries automatically. If I pull my cursor back to the left, it'll only have this one boundary created here. But you just do, your first click is always your start location, and your next click is always kind of your stop location for your boundary. In this case, we only had one boundary for this particular bridge. It wasn't an overly long one. So sheets that are good for model-centric plans. Start off with the plan and elevation one. This is somewhat, I won't call it controversial one, but it's one that people can argue about whether they want to use model-centric plans for. The OBM training guide really goes into a good list of pros and cons of the P&E sheet, but what are the main pros of it? I'll kind of a quick overview of the pros of generating your P&E sheet from the 3D model. The first one will be the speed of the creation. You can really create your P&E sheets very quickly when you're using model-centric plans or using the 3D to 2D plans production workflow. You're cutting through the roadway terrain automatically, whether it's existing or proposed terrain. So that line work gets generated automatically for you. And having to try to draw that line work or manually based on the information you just get from roadway plans or cross sections can be kind of a time-consuming process to get it right. So that is done automatically, just cutting through their terrains, and if their terrains change, then your line work on your elevation view will change. So that's definitely a big plus in that sense. And also, kind of like this piggybacking off of that, if anything changes in the 3D model, let's say I change my beam type or my barrier height or anything like that, any changes in the model automatically get updated and kind of propagated through the dynamic view workflow into the sheet model. So there's no extra redrawing or anything like that. All you're doing is just updating the model, and the plans get updated automatically. Some of the cons of the 2D or the model-centric plans for the P&E sheets, I would say would be the one that really gets, and this is where it gets people arguing, is that the curved bridges will look a little different in an elevation view. Just because you can't get, the way we draw the elevation views are these kind of flattened out, technically unrealistic view of a bridge, but we do it because it's easy to just convey the information that we want on there, and it's kind of a graphical view that's not used for construction by any means, since it's not true in a sense. You can't get that out of OBM. When you're in an OBM, when you're cutting through something like a curved bridge, you can't cut along or following the curve to get that kind of flattened out view. There are some ways to do it, but they all have drawbacks, and so many drawbacks that we decided not to adopt any of those things. So I'll jump out real quick. Actually, just pull my PDF example over here to see what I'm talking about. So here's kind of what you would get out of OBM or a 3D model on a curved bridge in this elevation view. So this is not what we're used to seeing, right? This perspective view where we can kind of see how the pier would look if I was standing, right. I think this one was probably right about here when I was looking at this one. You're just looking. It's almost like a perspective view. What am I going to see if I'm standing in a certain spot of the bridge? So you're going to see this kind of isometric view in a sense, or perspective view here. And you can still do your dimensioning and everything, because the dimensions we put in those elevation views are all hand done anyways. But you get your nice automatic cut of the ground line here and everything. So some people don't like the way this looks, and so they say, no, I want my elevation view drawn, by hand in the normal flattened out view. Some people say, yeah, this doesn't really matter, so that's fine. Let's just do it this way. Up to you. It just depends on the project, the reviewer, and what your preference is for that. All right, so another one that is good for typical section, or good for plans production using the model, would be the typical section superstructure section here. And the one, that's a good one because it's really easy to do and it's very quick, right? You can use the section callout tool, or usually actually the better one for something like this would be, there's a specific one in OBM that's a section kind of call out by station. So you can put in a station and it'll keep itself orthogonal to the alignments, which is what you want. Or you can actually skew it. You can give it a specific skew angle, and it'll basically put that section cut at that specific location. So it's very quick and easy to do typical sections or superstructure sections with the model. So one downfall of that, though, if you want to call it that, would be that supplemental line work doesn't move with the model, like if the profile changes. So let's say, and you normally you wouldn't detail anything in great detail if it's so early on where the profile is going to change. But let's say you did, or let's say there was a profile bust and then the profile had to change late in the game, and I had drawn in like all my little dots for all my rebar and extra line work that are kind of hand drawn in a drawing model to kind of supplement the section view that I created from the 3D model. Well, if that profile view changes, those supplemental line work that I draw in there, that doesn't change with it because it's not tied to the model. Now, it's not a huge deal because you can figure out, okay, well, how much of the profile raise or lower, and if it got raised by 2 inches, then I just select all that supplemental line work and move it up 2 inches in the drawing model, and you're done. So it's not a huge burden, but it's still just something to kind of keep in mind and consider when you're going to do these things. One thing too that you kind of get with the typical section view currently in OBM is you get certain lines that you don't want to see necessarily. So, for example, the one that people always kind of talk about or argue about is the haunches. So haunch elements get modeled as their own elements, their own 3D element in OBM. Decks are separate from the haunch in terms of the elements in OBM. And because they're separate elements, you're going to see a line there at the interface between the deck and the top of the haunch, which the line technically doesn't exist because that haunch gets poured in with the deck. That's all one pour. And that line you don't want to see that necessarily on a set of plans because it could be considered a construction joint. Although I think everyone knows that when you're pouring a deck, you're going to pour that all in one pour. But so one thing you might have to do if you don't want to see those little lines, and it's just a little detail kind of thing, whether you care about that or not, but you would have to use like a masking element. So you have to kind of cover it up with a microstation drawn element that has a background color as set as the level color, which we do have those specific levels. We've introduced extra ones over the last I think like 1 or 2 workspaces ago to help with things like this, where we can mask out things that we don't necessarily want to see. But just something else to kind of consider with doing plans from the 3D model. And plan view sheets, these are generally pretty good, pretty easy to do with the name boundary tool. So we're talking, foundation layouts, superstructure plans, approach slabs, anything that you want to get more plan views of. Those usually work out very well with 3D model because you're turning all the 3D stuff off and you're just using the 2D decor levels, or we call them decoration levels. That's kind of Bentley's term for the 2D line work that gets automatically generated by OBM, based on the 3D model elements. So you just turn off all of the 3D stuff and you're kind of back to working in your normal 2D world, and you can use that place name boundary tool and really crank out your sheets here, any of these plan view sheets relatively fast. All right, so we kind of went through some of the sheets that are good for 3D to 2D plan instructions. So which ones are not, or you can say it another way, what sheets are good for the traditional 2D drawing? And before I even click on the first one, I mean, really, it's any of them. You can draw any, like I said earlier, you can draw any of your planes in 2D as you always have. No restriction on that at all. But some of the more custom details that aren't necessarily modeled in the OBM model, I mean, they could be if you wanted to take the time and if it was worth the effort of doing it, but in most cases, they're not. So we're talking like steel girder elevations, although Bentley did just introduce a new feature where they can kind of automatically create steel girder elevations based on the model, and it actually is that flattened out, unraveled view that we need and are used to in steel girder elevations. But it's not, I wouldn't say it's not ready for the big times yet, so it's not turned on in our workspace yet. Steel details, you know, any really in the weeds close-up views of bolt pattern layouts and shear studs and some of the complex interfaces that we detail out. You know, a lot of that stuff we can model in there, but in order to get it in the perfect way that we would want to see it in a 2D view, it's hard. Because a lot of times when you model something in there, you kind of draw it out in a way that's kind of, again, an idealized view of it. It's not necessarily, you can't really cut a straight line through something to get that particular view. So yeah, steel girder details, some of the cross frames and diaphragm details, again, I wouldn't probably do those in OBM. The cross frames, diaphragms, you can model all those totally accurately in any way. You know, all the built-in tools, they're really great, very accurate, but it's just a lot of that stuff kind of just becomes complicated when you try to cut sections through some of those things. Superstructure section, kind of what we talked about earlier, you know, those superstructure sections, if you're drawing those early and you're manually drawing in your rebar, then the rebar is not going to move with it if profile changes or anything like that. Expansion joint details, that would be another one that, you know, you're not really modeling the expansion joint. Like if it's you know, something complex like a finger joint or a modular joint, you're most likely not going to be going through the effort of modeling those unless there's some worry about the interface between components that you want to make sure there's no clashes of. It's actually, a lot of times there can be some issues with modular joints in the decks. Finger joints, but I mean, you can model like the gap for, let's say, you know, like a strip seal or a poured joint with backer rod. You know, that's nothing. That's just the gap, and then you have backer rod and stuff in there. Strip seal, you have the I guess the steel components in there, but you know, that kind of stuff. It's kind of one of those things where you take a step back and say, okay, what value am I getting out of the effort that I'm putting into modeling something like that? And so we generally don't want to model those. We don't need to model those. It's not worth the time or effort. Tables, you know, we don't really produce tables from a model. All that's kind of misleading because we do get, you know, finished grade elevation tables and things like that, and we do massage those a little bit to be in the format that we want in the end. So we do produce some from there, but it's not like one click and you're done. You're just placing a table and it's linked like to the model or anything like that. Modified standards, that's going to be another one that, you know, you're not going to be taking the time to model something like that and cut sections from the model. You know, just take the standard DGNs, modify them as needed, and throw them in the back of your plan set and call it a day. And then elements not modeled. So certain parts of like the thick and thin slab, we might not be modeling. There's ways you can do it, and and it gets very close, and they kind of get better and better with each release. But again, what am I gaining out of modeling the thick and thin slab? You know, there's not going to be any high risk for clashes or anything there that's going to cause an issue. So that's just one of those things where you say, is it worth the time? All right, F. Display styles. We're kind of in the last couple things here. We'll probably actually finish a little bit early, give you some time back. But so display styles is something that you might hear often referred to or talked about, and you're like, okay, what exactly is a display style? So if you go up in your view window up here and you click on the little drop down here, you're going to see all these different display styles. Now, some of them we've got set up for certain reasons, like mostly these ones up here, these opt-out ones are going to be for the section callout tool and different tools that we want to basically control how things look in that 2D drawing model when it gets created automatically for us. That way we don't have to go and make those changes every single time we use that tool. And the rest of these are going to be out of the box Bentley ones for the most part. And the two that are obviously the ones we use the most are going to be automatically set up for you as the default in view 1 and view 2. So view 1 default should be the wireframe display. That's the one that I honestly am in 95% of the time, because that's what your view that you're in, that you're going to be measuring things in and moving around. It's the view that kind of is the most efficient in terms of the responsiveness of the model. If you have a really big model and you're trying to look at, you turn on like the fancy rendered view, then it might be a little bit laggy, but this is going to be the best performance, this wireframe view here. The other one that we do use, we like to take screenshots and use them for graphics, or kind of just, sometimes it's just easier to visually see things in this rendered view. Is going to be the illustration, ignore lighting view. And that should be the default for view 2. If you turn on view 2, this should automatically be set up as the illustration or lighting for you. This is a good one to turn on and use when you're trying to check interdisciplinary coordination. So when I want to look at, okay, how is the roadway ORD model lined up with my approach slab here? How are their walls lined up and wrapping around my abutment here? You can check that in the 2D wireframe, and there's certain things that are good about checking it like that, but it's a lot quicker and easier to just kind of, at least for your first go, your first review, to turn it on the illustration or lighting, use this displays file, and look to see how, again, the other disciplines, more so the roadway corridors, are interfacing with ours. You're going to see real quick that things are lined up, horizontally and vertically in this particular view. Display rules. So these are something that I'm not sure how old they are. They haven't been around for forever. I think they're only about maybe 8 years or so old, but still relatively new in like the overall, Bentley world. But they're very, very powerful. They can be used in a lot of kind of interesting and clever ways, some of which we try to do in our workspace here. So they're used to help level management and override symbology or appearance. So you can use display rules to change, the color of elements, to change the line weights of elements, line style. You can use it to turn certain things off, change the material, and it's all a temporary change. Like, it's just a rule. You can turn the rule on, and it'll make these changes visually, but it doesn't actually change the properties of the elements themselves. Because a lot of times when we're doing, especially like 3D to 2D planes production, we're going to get things looking really close, maybe like 90% of the way there in terms of how we're used to seeing it. And maybe we can use a display rule to get us from 90 to 100%. So it looks exactly how we're used to seeing it, or at least from 90 to like 99%, something real close. So in this case here, this is a display rule that we created for the planet elevation sheet generation, and we kind of document this and talk about this in the training guide. So we created this rule here, this structure, PE plan view, and what all that really does is when I apply this rule, I turn this rule on, like in my wireframe view, which I have the wireframe view turned on here. That basically turns all of the levels off in the model, and then only turns back on the ones that I want to see in my plan view, which are my 2D decoration levels for like the barriers, deck, and support lines. So instead of having to go in and manually see, okay, I want to turn off, this 3D element, I don't need this or this or this, I can just go ahead and apply this display rule, and it'll do that work automatically for me. So anytime that you're going to do something frequently in terms of manipulating level symbology or wanting to change how things look, you might want to look into creating a display rule for. Another way that we use display rules would be for rebar modeling. So the way our levels are set up in the FDOT workspace, we have like 15 different levels for each concrete component that contain rebar. So we have like 15 different levels for footing rebar, 15 different levels for column rebar and cab rebar, and so on and so forth. And the reason we do that is because we need to be able to put different sets of bars on different levels so we can turn things on and off and be able to manage the rebar and the models a lot easier. But even with doing that and having, okay, footing is green and column is blue and cab is orange, I look at this picture and I'm like, okay, this just looks like a blob up here. What exactly is going on in here? And now I'm in a zoomed out isometric view in a PowerPoint, so it's kind of exaggerated here. But you kind of look at the picture, I can make a display rule to change the color of all the levels that are used for the rebar elements. And when I do that, then I can get something that's much more clear, much more easily digestible, especially when you're working with rebar and congested caps and congested areas. It's just, you get so many lines that represent the edges of the bars, and you can just really get lost in there at times. So using a display rule, I said, okay, go ahead and change, cap 1 level to blue, cap 2 level to pink, cap 3 level to purple, and then it's just a lot easier to see what you got going on in a rebar model here. I can tell, okay, I got a set of bars up in the top here. These must be spliced to the other main bars coming out here. My stirrups and the ledge here are blue. And then when you're really in the model and you're zooming in and around, this display rule in particular really comes in handy. Another one here would be like a section view. So if I want to go and look at a section view of my rebar model from the side view, again, I got orange is cap bars and blue is column bars, and that's nice. That's a good distinction. But it's still like at first glance, I'm like, okay, where are my stirrups at? Do I have one big one? Do I have a bunch of little ones? It's hard to tell just at first glance. But turning on a display rule, it's again much easier. All right, I can tell, okay, this outer one is this turquoise one, so I got that. I must have some variable ones at the end of the cap that are coming up, or that taper is. I have these red ones. These are my internal or interior stirrups here. Okay, I got these ledge bars and my main ledge bars, and then the blue ones down here. So it's just, again, a lot easier to see what you're doing, especially in rebar modeling, when you use a display rule like this to just, again, temporarily override level symbology as needed. And that is the end of our regularly scheduled program. Kind of left a little bit of time here for open forum, open topics. We'd sent a poll out a while back to kind of get feedback on what was going to be beneficial to talk about in the training today. But we wanted to leave time open here for anything that's specific to you, specific to your district, to a project you're working on, a project you've worked in the past. Any questions at all, totally open forum, open discussion, if anyone has any questions. Or comments or feedback on what you guys want to learn more about in future presentations.
They're all thinking. I want to thank Heather, and I want to thank Steve for their efforts and for putting all of this on for us today. I'm looking at all the attendees right now, waiting for somebody to put in any kind of question and comment. But you guys did a great job. Thank you so very, very, very much. Everybody, now's your chance. I don't see anything coming into the questions. I can try to come in and unmute you as well if you'd rather just raise your hand. And I can see about turning your mic on if you'd rather just talk. Oh, David is, let's try to unmute David really quick. David, you're marked as self-muted. There
Do
you
you
go.
hear me now?
I can hear you now. Mr. David, you are on the air.
Oh, okay. That puts a lot of pressure.
Not at all, not at all. No, now's your chance to talk to Heather and Steve.
No, first of all, I want to, yes, I have a question for them, but first of all, I want to thank them for the great presentation that both of them gave. I was wondering if in the future there could be some coordination to provide some updates on how to work on different elements that SS10 we used to work, like for example, the reinforcing rebar list. I know that there are differences right now. We're right now using more 2D workflow, not so much on the 3D yet. That would be one item. Um, the reinforcing bar list, and the other item kind of when we have like a special like a special Excel sheets, like for example, like for the finished grade elevations. In the past, we used to use LDM, but right now the workflow is kind of different. You know, every table is put us in the border model, which is one-to-one, different as to how it used to be done before, and you know, specific tables like finished grade elevations are kind of becoming a little bit of a challenge. So I don't know if there could be some kind of coordination also to explain what's the best way to do it right now with Connect, and that's what I wanted to share from my end. Thank you.
Sure, sure. So I can take that. So the first one about the rebar tool. So they did redo the rebar tool. I personally think it is significantly better than it used to be. No knock on what it was before, but they did a really great job with the update on it. And there's actually actually Heather did a training on that. It's on the FDOT YouTube page. I can grab a link real quick here and toss it in the chat for you. That should give you pretty good.
I have the link, Steve, so you can cover the second one, and I can paste the link, the YouTube link in the chat.
Okay, yeah, and then post the white paper we did too, because we did a kind of an update to how we placed the rebar table. It's a little bit more user friendly, and we did a little guide, like a little short couple page white paper on that. So we have a link to that in the chat here too. Regarding your second question, let me turn my little PowerPoint pointer off here. And so with regards to tables, we do have instructions in the FDOT OBM training guide on how to do tables and work with those. And if you actually just, whenever you create a work set, you know, your project work set, like this was like a testing environment that we were testing the new workspace for here, but let's just pretend like this is some FPID number here. This is the standard structures folder structuring here. You go into the structure.
Might be on the PowerPoint screen.
What? Oh, wrong one. Yep, that would help. Let me get out of that, or I'll just bring it over here. Okay, can you see it now?
Yeah, we see. Well, we see the file explorer.
Perfect. Okay. So yeah, when you're in your folder structure, right, all the different disciplines in here, you go to structures. And in the ENG data folder is going to be this structure standard data tables Excel file. And if I open this guy up, it actually should have all the instructions on like how to use it on the first tab. So let me pull this over here. Yeah, the instructions tab we got here kind of explains, okay, how do I reference in tables from Excel if I have a standard data table seed. So all the standard data tables we have in our plans, we should have a table seed for those. And that would be under this first category here. And it kind of goes into detail on how to place that table, how to adjust the cell range to be exactly what you want in your Excel file. And then also how to place tables that don't have a custom table seed. So finished grades is a good example there, where you know the number of finished grade T lines in this table is going to change depending on the bridge and the length of the bridge. So we don't have like a standard table for this. We do have a starting point though, where you can start in here with it and adjust this and fill this out. And then we have instructions on how to place that custom table with no table seed in here, adjust the formatting of it and make it look like how you want to. And then also how to refresh your tables. You know, let's say you updated your Excel table and you need to get the MicroStation table element updated. Explains how to refresh that in here for a single table or even multiple tables all at once. So yeah, all the standard ones, like I said, should be in here for you to fill out, and instructions should be in here how to use them. So if you have any questions about that, then feel free to ask those, or if you don't have any now and you kind of dig into it later on and you have some, feel free to reach out.
Steve, my apologies, maybe because I missed a portion of what you said. What is that document that you're showing right now, especially for the finished grades? I'm sorry, I might have missed that part.
Sure, yeah. So anytime you create a project, and for CAD, I'll just call it that, we have the standard folder structure here, right? All the different disciplines. We got our structures folder. In the structures folder, in the ENG data folder, will automatically be a file that gets created for us for each project. When you click on that file and open it up, it'll have every standard data table in here that we place in the plans. So bearings, the build up and deflection, all of them, they should all be in here, and you can fill all those tables out in here and then link each one of these to the plans following the instructions on that first tab here.
Got it. Thanks so much.
Sure, yeah. And that's a common question. People were so used to using LDM for years and years. Yeah, this is kind of the way that we're pushing, because it's a good workflow, it works well, and connecting directly to the Excel file is nice through this tool, because it even works on ProjectWise, which a lot of the consultants have to use. Did that answer your questions, or do you have anything else?
No, that answers the questions. I have to put that in practice, of course. Right now, I have to read. I might have further questions when, but thank you for now. I mean, you both did a great job. Thank you.
Sure. Yeah, no problem. Like I said, feel free to reach out anytime you have questions, even if it's just putting in a ticket for a question. It always gets routed to us, so we'll always be there to answer it.
Okay, everybody, any other questions? Now's your time. All right, having heard none, having seen none, no one else has their hand up. Heather, Steve, I'm going to let you say your final goodbyes, and then we're just going to cut it on out. And everybody, I hope you have a great day. Thank you again.
Yeah, thank you everyone for attending. And like Steve said, if you ever have any issues or questions, go ahead and create a ticket, and the central office CAD team will route it to us, and we'll be able to answer everything. Have a good rest of your day.